We have two guys, A and B. They are workers to build a chimney. For A, he can finish the chimney in 9 hours if he works on himself. Constant rate. We assume it's constant rate. For B, it takes 10 hours. If they work together, it will be faster. So they took them 5 hours. Why? Because they talk, right?
Oh, but their speed is not the same. It's
Right.
actually slightly smaller.
Yeah, for this part, their speed is constant. For this part, the speed is constant. For this, they decrease by 10 bricks. So if this guy can do 20 bricks per hour, this guy can do 15 bricks per hour, together, ideally, they do 25. Sorry, 35. But then they lose 10, right? So they end up with 25. So I love this problem from AMC contest because it's fun. Not only is it fun, it's in my point of view, it's a clearly what? Speed and a rate problem,
Yes.
right? Does that make sense to you? Or does that make sense to you guys? Seems like there's no running, right?
Mhm.
But there's a time. So I usually call all these problems about a time and how fast you can do, and a job, a work, or I call them as a work rate problem rather than distance rate problem.
Yes.
Because you are finishing a whole job. Distance is like you are running, right? But
It's
the job,
of your
the job is also something you need to finish, right?
Mhm.
So if we think this is as a distance to rate problem, what is the distance here? Can you guys give us an answer? What is the distance we want to finish?
and a good way to denote it.
Yeah.
So one way to say the distance is the length of the chimney, right? Or the chimney itself,
Right.
because they produce at the end of the work the chimney that is built.
Right. But you cannot define chimney as the length, the height, the volume. You should define it as what? The bricks. Because that's your unit. You are talking about this chimney have how many bricks that you finish the packing of. Right?
Correct. So our distance is going to be the length of the chimney.
The number of bricks in there.
Yes, and we can denote it m bricks.
Right. Yeah.
And this is our distance.
So with this in mind, whenever we solve distance, rate, and time problem, we always want to make a table. R, T, and D. And then it's very clear we have player A, player B, and player A and B. We have this information, right? So now, complete this table, and if you complete it well, you have a good chance to complete the solution on your own.
I know everything in the last column. It's going to be just my distance. It doesn't change, right? M bricks here, M bricks here, and M bricks here.
Right. I also know this, 9, 10, and 5. That's for sure also, right?
Right. So now you know the rate, right?
Uh-huh.
The rate here is going to be M over 9.
Yeah.
M over 10.
Uh-huh.
And M over 5.
Yeah, that's the key, right? This is purely from this table. Now there's only one condition we have not used. Which one?
The rate when they work together is different than just the pure sum of
Right.
their
So the
rates.
equation becomes m over 9 plus m over 10 minus 10 is equal to m over 5. Because if they don't talk on their own, he will be this. So if you work, then they will be this fast. But somehow they talk, they lose 10 more. So this is the answer, right? To be more clear, this is unit, is brick, bricks. This is hour. And this is bricks per what?
Per hour.
Per hour.
Yes.
Right?
And this is the unit we have here.
Exactly correct.
They could give you minutes.
Yes.
Then you have to exchange units.
Yes. So now we don't have to, right? So with this in mind, it's very easy to solve this equation, right?
Yes. We have a common denominator 90.
Uh-huh.
So 10m plus 9m minus 18m is equal to 10. I brought m over 5 on this side and 10 on the other side. So m over 90. 19 minus 18 is 1. So m becomes 900. So we have 900 bricks in our chimney.